Hello, Algebra 3. Again, we are going to be working on application problems. This is the last of the 3 application problems that we'll be working on in this chapter. And again, it's over linear equations. We'll have other application problems in probably the next chapter, but this is the last one in this chapter. So section 2.4. Here we go. One of the types of problems that we'll be dealing with are called motion problems. And a motion problem is one in which an object is moving at a specified rate for a specified period of time. So how we're going to calculate this, here's the formula. It says amount equals rate times time. And here we have a little example for you. It says, example 1, a typical shower uses 30 gallons of water and lasts for 6 minutes. How much water is typically used per minute? So what we're looking for here, it says how much water is typically used per minute. That means we are looking for the rate in this formula here. We have the amount, that's going to be our 30 gallons, that's A. And we have the amount of time that the shower is running, 6 minutes. So let's go to the next slide and solve this out. Amount equals rate times time. So 30 equals our rate, which we are trying to figure out, times time, which is our 6 minutes. Simply divide both sides by 6, and our rate is equal to 5, which means the shower is running at a rate of 5 gallons of water per minute. And there we go. We're done with that one. So the next one is going to be about distance. So distance problems use this formula right here. Distance equals rate times time, or D equals RT. Again, here we have an example. It says, Fred can ride a scooter at 15 miles per hour. That's our rate. Tom can pedal a bike at 9 miles per hour. There's another rate. They start at the same distance traveling towards the same destination, meaning they both go the same distance. Fred arrives at the destination 20 minutes ahead of Tom. How long does it take Tom to arrive at the destination? To simplify this, I'm going to show you a table on the next slide, and this is how we're going to put together our equation that we're going to solve, okay? So let's go. So we have people here. We know we got Fred and Tom, and they're both either riding a scooter or pedaling a bike at different rates, and Fred is going at a rate of 15 miles per hour. And Tom is going at a rate of 9 miles per hour. And in that slide, they said that they start at the same time traveling towards the same destination, and Fred arrives at the destination 20 minutes ahead of Tom. What I'm going to take this as is Tom arrives there 20 minutes earlier. So I'm going to say time equals, let's say x minus 20, but this is in minutes. So, and our rate is in miles per hour. So we got to convert our minutes to hours just by dividing this by 60. Okay? I hope everybody understands that. If not, I will explain it to you more in class. And then Tom, he just arrives there, and that's what we're going to figure out. That is our x value. So Tom gets a value of time of x, and Fred gets x minus the amount that he finished before Tom. Okay? Now distance. So remember this formula up here, distance equals rate times time. So what goes in our boxes here are going to be our rate times time. We're going to just multiply straight across. So 15 times our x minus, and then I'm going to change this to a fraction. That's 1/3. And then 9 times x. All right, so now what it says is our distances here, they're the same traveling distances. So our distances are equal to each other. So there's our equation. Our 15x minus 1/3 is equal to 9x because our distances are the same. And now we have our equation and we're going to solve. So distribute that 15. And then now solve for our x value. So x equals, I'm just going to take a shortcut here because I know you guys can do this. X equals 5/6. But this is in hours, and our question is, well, I guess we can say 5/6 of an hour, but we can also put this in minutes just by multiplying 5/6 by 60. So our time that Tom finishes is 50 minutes. So it says that answers our question. How long does it take Tom to arrive at the destination? So 50 minutes. If it had asked how long does it take for Fred to arrive at the destination, we would just take our x value here that we found and plug it up into this right here and figure out what our value is there in minutes. Okay, next problem. All right, I like these problems. You'll probably be quizzed over these types of problems, so pay close attention, okay? Mixture problems have this formula right here. Amount equals strength times quantity. And what we're going to be doing in our problem is we're going to be combining two things together called a mixture. And when we're combining two things, we're actually adding two things together to equal the mixture. And you'll see that in this problem. So example here, a chemist has 10% and 16% acid solutions. How many liters of each solution are needed to produce 30 liters of 14% acid solution? So strength here in our table that's going to help us come up with our equation are all these percentages that we have, the 10%, 16%, and 14%. Okay, so the chemist has 10% acid solution, a 16% acid solution. These two are the ones that are being mixed together. And the reason I know he's not mixing together the 14% solution is because the mixture always has to be between the two other percentages that they are listing. So 14 is between 10 and 16, okay? So that is our outcome. That is the outcome of our mixing the 10% and the 16% acid solutions together. Okay, now we're going to come up with quantities for all of our mixture or all of our acid solutions. We know the 14% is 30 liters. That's what we're trying to come up with. So plug in 30 in our table here. And we don't know how much of the 10% we need. So we're going to call that X. Okay. And then what we're going to call the 16% solution is 30 minus X. Because what we need to come up with whenever we add these two quantities together is 30 liters. So if we add these two things together, we would have X plus 30 minus X, which equals 30. And that is our mixture solution amount down here. I hope that makes sense. Again, I will explain more in class if that doesn't. But to keep going, our equation, or our formula up here, strength times quantity equals amount. Again, we're going to multiply our rows straight across to get our amounts in this column here. And let's see, 10% times x, change your percentages to decimal, so 0.1x, and 0.16 times our 30 minus x, and then our 14% times 30, that is going to equal 4.2. All right, so to get our equation, we look at this last column right here. And what we're going to do is we're going to say the first amount mixed together with the second amount, so adding those two together, equals the last amount. So that is our equation, the 0.1x plus the 0.16 times 30 minus x equals 4.2. And that's what we're going to solve on the next slide. And then we're going to figure out each quantity. What we're figuring out is our x value. And so on the next slide, after we figure out what x equals, we're going to figure out how much of each solution we need. So how much 10% solution we need and how much 16% solution we need to make that 14% acid solution that is altogether 30 liters. Alright, so writing our equation that I've already said, 0.1x plus the 0.16 times 30 minus x equals the 4.2. Okay, so solve the equation, distribute, and that equals, no, let's see, 4.8 is what that equals. Minus a 0.16x equals 4.2. Alright, now combine like terms. So we have like terms right here, which is going to equal negative 0.06, and I'm going to go ahead and subtract the 4.8 from both sides, which equals negative 0.6. Oh, I forgot my x. There's supposed to be an x right here. But anyway, keep on going. We're going to divide both sides by the negative 0.06. Remember, a negative divided by a negative is a positive value. So we end up getting 10. And what this means is our quantity for our 10% solution is equal to x. So we need 10 gallons of 10% solution. And remember, our quantity for our 16% solution was 30 minus x. So we need 20 gallons of our 16% acid solution. So there we go. We solved for our both quantities that we need to make up our 14% acid solution. And that is all the problems that I have for you on this video. So I will see you in class. Bye, everybody.